All right, students, in this video, I'm going to make it two parts. One part for isosceles triangle, and then the second part for the equilateral triangles. So for isosceles triangles, let's review what the parts of the triangle are called. So when you have two congruent sides in the isosceles triangle, these are called legs. So these two right here, these are your legs. The angles where the legs intersect is called, and then that's this point right here, imagining that the lines keep extending, and this is the vertex for that, or where they meet. So that angle right here, this is going to be called the vertex angle. Next, we have the side opposite to the vertex angle is called so they're talking directly about this one right here. This is called base. The base of the triangle. And then the angles along the base are called, these right here, they're called base angles. So speaking the language, we're going to assume that these two angles, base angles, are going to be congruent if the legs are also congruent. So right here it says if two sides of a triangle are congruent. So if the two sides, meaning the legs, are congruent, then the angles opposite, which are the base angles, are also congruent. We're going to have AB be congruent to BC if and only if, or if these are congruent, then the angles are the same. Angle A and angle C. So if these two are congruent, then these two angles are the same. The converse of that will be the opposite if two angles of the triangle are congruent. So if these two angles, the base angles, are congruent, then you are to assume that the opposite, the sides opposite to the angles are congruent. So these two right here are congruent. So as an example, we're going to say the opposite of this. So angle A is congruent to angle C. If that is true, then the legs, the AB, is congruent to BC. So with this, we can apply now the process of solving for missing values, missing angles, or missing side lengths. We understand once again, as soon as you see these notations, it's an isosceles triangle, which means that these two base angles are also congruent. That means that when they ask you for measure of angle J, we are to look at this angle and say, oh, it's also 68. These are congruent. Measure of angle K up here can be found by understanding that the inside of a triangle is adding all the sides and it'll equal 180 degrees. So and adding J, K, and L. Since we already have the 68s, we can assume that 2 times 68 plus the K equals 180. So when we multiply 2 times 68, we're going to get 132, no, 36. And then 136 plus an angle will give you that 180. So we subtract the 136 from both sides, and K equals 44. All right, so that's how you will find those two values. For number 2, we have an isosceles triangle because these two are marked equal, which means that the base angles, so I know this triangle is upside down, but if you look at it like this is considered your base, which means these are the base angles and they're congruent. Since they give you 106 for this corner right here, we can assume that 180 degrees minus 106 is 74. That means that these two bases that are congruent, they add up to 74. So because they're equal or they're congruent, we're going to divide 74 by 2, and that's going to give us 37. So the measures of the angles are 37 each. 37 plus 37 is 74. 74 plus 106 is 180. Number 3. The triangles are talking to you. So like right here, they're not giving you dash marks, but they're giving you the side length of 12, these two angles as 77. That means that if these two are the same, then these two angles are the same. The sides are the same. Therefore, YZ is going to be also 12 centimeters. And measure of angle Y, which is up here, can be calculated by adding these two. So 2 times 77 plus the angle Y equals 180 degrees. 77 times 2 will give you 154 plus Y equals 180. Subtract 154 from both sides. Y equals 26. Right, 26 degrees. Number 4, 5, 6, and 7, it's pretty much what we're doing right now, but with expressions. So now you look at what you're given. You're given two lines that are dashed to be congruent, which means that these base angles are also congruent, which you will write the equation 5x plus 9 equal 8x minus 30. And to solve this equation, isolate the variable. So I'm just going to move the 8x to the left side. And that results in negative 3x plus 9 equals negative 30. And then we're going to subtract 9 from both sides. And negative 3x equals negative 39. Last step will be to divide by negative 3. And x equals positive 13. It's asking to find each variable, so we're done finding that variable. Let's try number 5. These two are the same, which means that these two are your bases. So we're going to have them equal to each other. And to solve, you can do whichever way you want. I'm doing the x to the left side just for practice. And then we move the 7. And then we divide by negative 5. So x equals 8. All right, these two examples are following the same as the previous two. So I'm just going to help you set up the equation and then you can just solve for x. These two are telling you that these are congruent. Therefore, those are your base angles. And that means these two sides are congruent. So we're going to have 15x plus 7 equals 23x minus 17. And then you solve for x. And when you solve for x, your answer should be a 3. On the next example, we have these two angles being equal, which means that if I turn it around, these are your base angles and these are congruent sides. So we're going to write 9x minus 73 equals 3x plus 23. And when you solve for x, you're going to get 16. All right, let's look at the back. We have the same process, but without a sketch. You have to draw the sketch here. So if triangle RST has RT and ST congruent, that means that RT and ST meet at point T. And that creates your triangle. It says to find the measure for x, find x and find the measure for each angle. So we already know that these two sides are congruent. So let's start with those. RT, oh, they're not sides, they're angles. So then if these two sides are the same, we know that these angles are also the same. So measure of angle R and measure of angle S. 9x plus 2 equals 13x minus 18. You solve for x. And I'm just trying to save some time here. X is to the left side. Numbers to the right side. Cancels here and there. And negative 9 minus 13 will give you negative 4x. Negative 18 minus 2 is negative 20. Divide by negative 4, and x equals 5. So this problem not only is asking you for the x, it's asking you for the measure of each angle. Now, because angle R and S are congruent, we can just find at least one of those. So we're going to do 9x plus 2. We're going to substitute 9 times 5 plus 2. And 9 times 5 is 45 plus 2, which gives you 47. 47 degrees for measure of angle R. Since this is 47, then this has to also be 47. And the top number will have to be calculated. 47 plus 47 combined, and then subtract that from 180. Or just look at the expression given for t and substitute the x value of 5. So that will result in 85 plus 1, which is 86. All right, so the next ones, 9 and 10, are similar to that. You guys sketch your triangle, label what they're giving you. D is congruent to E. These are the congruent sides of an isosceles, so that means angle D and angle E. I'll just write the letter. And DEF is a triangle, so DEF up here. DE is given to you as an expression. EF is given to you as another expression, and then DF is another expression. These two are the same, so we're going to use these two. 4x minus 8 equals 7x minus 35. When you solve for x, moving the x's around and the numbers around, you're going to get 9. So if x is 9, then you plug it in and check. And again, some of you take different routes, but like if these two are the same, then just pick one of those expressions to say that these two are the same. So DF, oh, we already did that, sorry. We're going to substitute the x in for the angle D. Actually, it's finding the measure of each side. Yes, no angles, measures of each side. So we're going to substitute the x for each expression, and then that will give us the answers for this. Like DE, it's x plus 4, and that will just be 9 plus 4, 13. Then you have EF with 4x minus 8, and that is 4 times 9 minus 8. And that is 36 minus 8. So that is 24. And then the last one is DF, which is 7x minus 35. Substitute the 9 in for the x. And that's 63 minus 35. And that will result in 28. All right, let me finish this video with number 10. And number 10 is saying triangle WXY has WX and WY congruent. So W is the congruent, the common letter. So we're going to have W up here. So WX, WY, they're congruent. If angle W has x plus 6 and angle X is 5x plus minus 12, and angle Y is 7x minus 48, find X. So we're going to find X with these two, X and Y. X and y. And we'll solve them by writing an equation. When you solve for x, this will result in 18. And from there, we substitute that to each expression to find the angle, similar to number 8 up here. So you have x plus 6, which is angle W, and that is 18 plus 6, which results in 24 degrees. And that's W. X, if we find x, we have y. So if we find x, that's 5x minus 12. And that's 5 times 18 minus 12. 5 times 18 will be 90 minus 12, and that will be 78. 78 is this side, so 78 has to also be the other side. All right, so that's the video for isosceles triangle.